All right, welcome again, pre-calculus folks. Going to do another short video for today about some other function properties. So we're going to talk about increasing and decreasing intervals for functions, and also extreme values, so like minimum, maximum values, stuff like that, some other vocabulary. So I'm going to start off with increasing, decreasing. In this paper, the notes page here is in Schoology. But increase and decreasing is pretty straightforward. So we're going to go through and see how to do these kind of intervals. So obviously, it makes sense to say this. So obviously, where things are increasing, that just means they're going up. There's all this happening. And if they're decreasing, they're going down. And if it's constant, then it's just horizontal, flat. Okay? So the only catch on this is where these are x intervals. So we really don't care about the y values. All we care about are the x values. And again, we're going to write the intervals just like we did on the domain from left to right. Okay, just like we did on the domain. Okay, and also just the x values. Okay, so take a look at my first graph here. So all we care about, so what I like doing here, honestly, is when I see a graph and I want to do my increase and decreasing intervals, I kind of find my maximum minimum points, right? So here's a maximum point, kind of a crest, if you will. So I kind of do a little dotted line through there. Here's a minimum point, and that's really all I have. It keeps on going on both directions on the far end, but those are kind of my maximum minimum points. And then I just see what those x values are. So this is at -3, and this is at 2. And that's it. So again, just like you're reading a book from left to right, it's increasing. And again, x values, it goes all the way over this way to -infinity. So -infinity to -3, it's going up. And then from -3 to 2, it's going down. And again, just x values. And then from 2, again, it keeps on going forever on to infinity. So we can do a little u here if there's a second interval to infinity. And that's it. That's the whole function, and that's the whole thing about increasing and decreasing. Now you may have a constant interval too. This one doesn't have anywhere where it's constant. So if there's nothing there, you can just write none or NA or whatever like that, and that's going to be fine. Okay. So increasing, decreasing intervals. Okay. Let's go and look at another example. And that's really all there is to it. Oh, one more thing. Somebody might be saying, why did I use all parentheses instead of like a bracket at -3 or what have you? I'm not going to be that picky. If you use a bracket on these, it's going to be okay. I'm more picky on the domain and range stuff. But in pre-calculus, there's not a good explanation, but I can tell you when you get to calculus, technically speaking, at those endpoints, at -3 and 2 in this case, it's neither increasing or decreasing. So that's why we use a parenthesis. But if you put a bracket again, but increasing and decreasing, I'm not going to be that picky. Let's look at the second example here. So again, take a look at this and go to any kind of minimum or maximum point. Just kind of draw a little line just to kind of give yourself a visual of what's happening. All right, and see what the numbers are. So that's going to be at -3, and it looks like that's at 1, 2, 3, 4, 4. 1, 2, 3, 4. Yeah. Okay. So again, you can just go in order. Easy way to do it. So the first section is decreasing, again, from left to right, going down. So from -infinity to -3. And then the next section is increasing, going up. So from -3 to 0. Remember, we don't care about the y value. So just -3 to 0. And then the next section is going down again, decreasing. So from 0 to 4. And then the last section going up forever and ever. So from 4 to 0. That's it. And again, there's no constant area, so you just write none for n if you want to. Okay. X values, interval notation, left to right. That's all you got to remember. Okay. One more example. So if you want to pause the video real quick, so here's your last picture. Go ahead and pause the video for just a few seconds. Write down, jot down on a scratch piece of paper what you're increasing, decreasing, and if there's any constant intervals on there. Okay, so what do you get? So again, if I do my little lines here, I got a line there, I got kind of something going on here, maybe something going on here. Okay, so that's at -3, and that's at 1, 2, 3, 4, looks like that's at 5. So again, first thing I see from left to right is it's going up. So that's going to be from -infinity to -3 for increasing. And then it's decreasing from -3 to 0. And then here's a fun one for you. So now notice it's horizontal. It's exactly flat. So it's constant from 0 to 5. You won't see those too often, but I like throwing one at you every now and then. And then from there on, now it's going down again. So it's decreasing also from 5 to infinity. Okay? All there is to increase and decrease, and it's literally all we've got to talk about. Okay? Last little bit of vocabulary I'm going to go and throw this in the same video. I'm going to talk about minimum and maximum values. Okay? And there's two different kinds. We kind of saw them in the graphs. In fact, I'm going to go back and look at the pictures again. It won't even be on this page. But the main thing is, again, a little bit of vocabulary. So if it's the highest or lowest point it ever gets to, then we call that either a global or an absolute maximum or minimum. Okay? If it's the highest or lowest point ever, it's either the global or absolute. Okay? And then if it's the highest or lowest point in an area, it might be a big area, then we call that either a local or a relative. And again, it can be either minimum or maximum. Okay. Now, if we talk about Venn diagrams, the other day we talked about like Venn diagrams for real number systems. Basically, all global extreme values, minimum maximums, are locals, but not all locals are global. So your Venn diagram, all of these things are locals, but every once in a while, depending on what the graph looks like, there's a subset that are global. Okay, so let's go back and take a look at the pictures real fast and just kind of label those different points that you see on the graph here. So I'm going to kind of get rid of my lines. And so this point right here, and again, to decide, it's definitely a maximum, so that's pretty easy to see. But now, is it local or global? You just ask yourself, does the graph ever get higher than that? And it definitely does, because it keeps on going forever up that way. So that's just going to be a local max. Okay, same thing here. This is a minimum. Does it ever get lower than that? It does, way over here. So that's going to be a local min. Okay, this one does not have any absolute max or min because it keeps on going forever towards infinity. So it only has local values. Okay, second graph that we did, again, I'm going to get rid of the lines. So, and again, just kind of label them, just kind of go one by one. So that's a min. Does it ever get lower? Obviously. So it's local. Here's a max. Does it ever get higher? Yes, that's local. So then this one down here on the right, that's a minimum, but it never gets below there because notice on both sides it goes up on both directions. So that's going to be a global or absolute max. Okay, really all there is to it. Okay, we're going to do that last picture just to finish that up. So again, take a look at this one. This one's kind of weird, honestly, with that little flat part. But for sure, we have this point. That's a global or absolute max. The other points are kind of weird, right? So there's some arguments. So like if you say at this point, well, isn't that a local minimum because it doesn't get any lower than that for a little while? I guess you can argue that. I'm going to put a kind of a question mark because since it's flat, I'm not sure if it's a minimum. But if you wrote that, I certainly wouldn't count it wrong. And the same thing here, like, what is this? So is it kind of a maximum because of this right-hand side here? If you want to call it a local max, I think it'd be okay. But there's also an argument that it's really kind of not a local max. But that's kind of what's going on with minimum and maximum values, okay? So you have a quick assignment on this tomorrow. I'm going to lump this stuff in with the even odd stuff that we're going to do on Friday. So until next time, stay safe.